Welcome to MyProjectBazaar.com. Let we discuss about the process relevance feature discovery for text mining. Let me see the abstract of the process. Many data mining techniques have been proposed for mining useful patterns in text documents. However, how to effectively use and update the discovered patterns is still an open research issue, especially in the domain of text mining. Since most existing text mining methods adopted term-based approaches, they all suffer from the problems of polysemy and synonymy. This system proposes an innovative technique for finding and classifying low-level terms based on both their appearances in the high-level features and their specificity in a training set. Input training documents were splitted into word by word. Each word in the training set is compared with the input query, and the frequency of each query is identified, and based on that the documents were divided into two classes. This support values for each classes were measured. The specificity value is calculated for each classes. The F clustering algorithm is employed in order to divide the input data into three classes. From the calculation of the minimum and the maximum specificity of where of each classes were identified, and based on that the classes were divided into three categories. The performance of the process is measured in terms of weightage, top 20 documents, F beta values, mean average precision breakpoint, and interpolated average precision values. Let me see the flow of the processor. First, the input training dataset is obtained. The training dataset is divided into D plus and D minus clusters. For each cluster, the specificity value is calculated. The categorization of the D plus and the D minus cluster is identified by the number of relevant terms in the each of the clusters identified. So if the relevant terms were more, means then they were present in the D plus cluster, or they were placed in the D minus cluster. For each of the cluster, the specificity value is calculated. From that, finally, using the F clustering process, the T plus cluster, G cluster, and the T minus cluster is obtained. The T plus cluster contains the most relevant documents compared to the image. G cluster related to the most common cluster of the image, and the T minus cluster compares to the more irrelevant documents in the images. Hence, we have classified the input training document set into three different categories based on the input query images. The performances of the processes is measured in terms of weightage, top 20 documents, F beta values, mean average precision breakpoint, and the interpolated average precision points. Let me see the running procedure of the process. The process has been developed in Skylab software. So in order to run the code, select the file main.sce, right click it, and click on execute in Skylab. The process will execute. So first enter the query for the processor. Give the query plants first. So we have to give queries like plants, animals, like etc. So we have given the data set in the form for plants, animals, and everything. The process has been done with the data set for plants, animals, flowers, and birds. So we have to give the query as plants, animals, flowers, or birds. So as we can see, the most relevant is document 5, common document is document 1, and the irrelevant document is these are all. These documents are present in the training data. The average weight WT, the WT minus WG, WT, and the average weight among D plus my two terms, they were all measured here. The performance matrices top 20 BP map, F beta, IAP, the values were displayed here, and the precision recall graph has been drawn statically in order to compare the performance of the process. Thus, we have categorized the input data document dataset based on the input query, and using that we can classify the text document from the input text data.